Hi, in a previous video I did about NuTone cassette decks or cassette players. You saw this cassette player out of an IM4006 master station that I used as an example and compared it to show the differences between this cassette player assembly and the cassette player assembly in an IM5006. This particular one, this is an actual cassette player out of this customer's 4006. Actually, it's a PTX 1201, but that's a whole nother story. Anyway, during the course of the rebuild of this master station, I found several problems with the cassette player assembly that needed to be resolved. You might have seen if you watched the previous video, which is the overview video of cassette players for 4006s and 5006s, you would have seen in the first part of the video when I disassembled this deck partially, the drive belts had begun to disintegrate and turn into this black tarry substance, and I talked a little bit about the pitfalls of that. Well, it turns out that in this player assembly it was much worse than what you might have imagined, so I thought I would show you what that was about and what you have to do to solve it. So what we're looking at is the main drive pulley, which is this assembly, and the pulley that's off of, and the pulley that's this one, let's see, and the motor pulley, which is the little one that I keep dropping here. And I do have gloves on because I don't want to get the black tarry stuff all over my fingers at this point in the day. So this is a little hard to show. So what happened to the player assembly that I showed in the previous video was the belts had disintegrated and turned into this black tarry goo, like this one, which is a real mess. And the other thing that happened is a portion of the belt wrapped itself around the motor pulley, and because this is very stretchy now because it's all falling apart, it wrapped itself around and around and around this little one. It got down between, the pulley fits on the motor shaft like this. It got down in the gap and it wrapped itself around and around the motor spindle. And of course, at that point, the cassette player won't come to its at-rest position, which means it won't turn off, which therefore means it runs continuously. And this is the motor out of that cassette player assembly. This motor is dead. It killed the motor and it made a big mess inside the player assembly. So what I did was I used replacement ones that I have that I've already cleaned because I didn't want to deal with the chemicals today. And both of these are salvageable and can be cleaned and reused. It's a matter of using the right kind of chemicals to clean away and dissolve the tarry, gooey black mess so the parts are reusable. This part, you're never going to find one of these to get separately. I'm not even sure if it was a part that was ever available to purchase separately from NuTone. These little motor pulleys, you probably could find an equivalent for it, but why go through the hassle if you can salvage the original? So once those were, the replacement ones were installed with new belts, I had to replace the motor also. Fortunately, I have a stock of these. They are new motors. They're not old or used. And I installed it in the cassette player assembly and reassembled the entire master station. And now I'll show you what you have to do after you replace a motor. On these little cassette motors, these are DC motors, and they run at 12 volts, and they are counterclockwise rotation. And this one runs at, I think it's 2400 RPMs. When you buy these from a vendor that sells replacement motors for cassette players, they don't come preset at any particular speed. They have to be adjusted after they're installed in the set. And right here, right here, this is an actual little port in the back of the motor housing, and there's a foam seal in here, and back down inside there is actually a little electronic motor control board inside here, and there's a little adjustment pot that adjusts the speed of it. So what you have to do is you have to reassemble the cassette player assembly completely. You have to reassemble the whole master station so it works again, and then you have to set it up so you can adjust the speed, and I'm going to show you how to do that. Alright, just to show you that it does work, let's pop in a little Van Halen. That's enough of that. We don't want to get copyright infringed on or anything like that. So we'll go ahead and take that out. And what you have to do to set the speed correctly on a cassette deck is you need one of these. This is a precision cassette assembly, and recorded onto it is a 3000 hertz sine wave, and this was done on a high precision calibrated cassette recorder. It was not done here in our shop. These are available. There are places you can buy these from. They're not inexpensive, so you have to take good care of them. But this is what you use. So you put this calibrated cassette assembly in the player. I have it hooked up on the back into the cassette player assembly, and I have it hooked up to my oscilloscope, and I'm going to show you two things. So the idea of this is we're going to play this tape, and it's going to play at whatever speed the motor is randomly set for as a replacement motor, and what we're looking for on the oscilloscope is a 3000 hertz signal, and then we can adjust the speed of the motor to achieve that. So let me go ahead and get this set up and I'll show you how it works. Okay, so what we're looking at is the oscilloscope, and what we care about to start with is this right here, down here. This oscilloscope has a built-in frequency counter, and when I turn the cassette player on, it's going to show the readout of the signal that it's receiving from the cassette player. So let's go ahead and start it up. And we'll adjust. Alright, so you can see here we have 3.12 kilohertz. It's supposed to be 3000 kilohertz, so this means that it's set a little high. So now I'm going to adjust it. So you can play around with it. And that seems pretty good. So now we're at 3.03. I might play with it a little bit more, see if I can get it down just a tad. How about that? We got 3.01, pretty steady at that. So that's really close. So we're going to leave it at that. It's 3.01. Now the other thing we're going to do is we're going to zoom out. And what we show here, this is a sine wave. We'll go ahead and calibrate it. Alright, so there's our sine wave. And what we want to do is adjust the head for tracking to make sure it's centered on the tape. So if I move it out of alignment, you'll see it reduce, and as you realign it, the peaks will become higher and higher. And there we're off the scale. So we'll go ahead and reset it so we can see the whole sine wave. And we'll fine tune it. And that's probably pretty close to right. So we made a significant decrease in the motor speed, and we aligned the head slightly. I notice our motor speed has increased just a little. So let's go ahead and touch that up. Alright, so now we're almost dead on 3000 Hertz. We have a nicely aligned head, so we're going to get maximum signal and maximum volume out of our cassette deck, and that takes care of the alignment procedure. So we'll go ahead and take out our high precision calibration tape. We'll put Van Halen back in. This may seem like a small point to do the motor speed adjustment and the head calibration, but here in the shop I have a selection of cassette tapes that I use all the time. I have 3 different tapes I listen to all the time that I use to judge how well a cassette player assembly is working, and even a 5% error in motor speed and head alignment is noticeable on music that you listen to all the time. So it's important to get it right. Besides, it's here in the shop, it's being repaired. It's only one more step to do to make sure when it goes back out it sounds just the way it's supposed to. So I hope you found this to be interesting and possibly helpful. If you did, please give it a thumbs up on YouTube. If you subscribe to our YouTube channel, we would appreciate it. That's all for today. See you on the next video.